Welcome. So we're going to answer this question before us. Now, just by looking at it, if tan of theta is equal to -1/3 and theta is between pi and 2 pi, find sine of theta and cos of theta, we immediately know this is a Pythagorean identity question. But I actually think it's easier not to strictly use that Pythagorean formula here. Rather, I think it's easier if what we do instead, if my computer wants to work with me here, is if we just draw out a right angle triangle. We mark in theta. I know that I'm dealing with tan, which is opposite over adjacent. And opposite over adjacent, it's saying is 1/3. So that means this is 1 and this is 3. So we're just ignoring that sign for now. So 1/3. Fantastic. Now, one of these is obviously negative, isn't it? One of these is obviously negative because it's -1/3 there. So we need to figure out which of these is going to be negative. To do that, we need to look at our domain. So let's look at our domain here for a second, and it will be helpful to draw ourselves a unit circle. Let's see if I can draw that a bit nicer. That's a pretty ugly unit circle. All right, so I'm between pi and 2 pi. Well, here's pi, here's 2 pi. I'm either going to be in my 3rd quadrant or in my 4th quadrant because I'm between pi and 2 pi, which means I'm here or here. Now, I've been told that I have -1/3. Now, in terms of tan, I like to think about this in gradient, okay? I like to think of the gradient of it. I know that all my gradients in my 3rd quadrant are positive. So it's not in my 3rd quadrant. It has to be in my 4th quadrant. So it's going to be somewhere, and I don't know exactly where it's going to be, but let's just say it's here. That is going to be what the angle is. Now, if we look at this for a second, let's just zoom in here. We've got some angle there. I'm going to have this, which is going to be my sine value. And I'm going to have this, which is going to be my cos value. Now, do we see that my sine value is obviously going to be negative? This right here is a negative sign because I'm below my x-axis. My cos is going to be positive. So that means I could come over here now, and what I'm going to do, because I'm trying to like replicate this triangle here, I'm going to say that this is -1. Okay, now we're going to continue. We're now going to figure out what x is going to be. We need to figure out what this is going to be here. This is where we use Pythagoras. So x squared is going to be equal to -1 squared plus 3 squared. X squared will be 1 plus 4, so 1 plus 9. X squared will be equal to 10, which means x is going to be equal to, now it's going to be the square root of 10. We don't have to worry about plus or minus here. Whenever you're dealing with the hypotenuse, you don't have to worry about plus or minus. It's because only cos and sine have signs on them, have like a positive or negative. The hypotenuse, or this right here, we don't think about as having a sign. So when you're dealing with these tan questions, that's just one of those peculiarities that you need to just remember. Okay, so once we've done that now, we can now figure out what sine of theta is going to be and what cos of theta is going to be, because we're just going to look at what we've created here. So sine of theta is opposite over hypotenuse. So opposite hypotenuse, it will be -1 on the square root of 10. And then cos will be adjacent hypotenuse. So it will be 3 on the square root of 10, because adjacent hypotenuse 3 on the square root of 10. And just like that, we have our answers. So just like that, we have our answers there and there. Again, what are the things that people mess up here? They mess up their positive or negative. So remember, because you are existing in your 4th quadrant, you know that the sign has to be negative. And again, because you're existing in your 4th quadrant, you know that your cos has to be positive. So that's the thing that you need to remember here. But yeah, hopefully this makes sense on how to approach this type of question. And yeah, hopefully using the Pythagorean identity, and especially examples where you're using tan, all makes sense here. Hopefully you found this useful.